Günaydın. In the last lecture, I was talking about mathematics. Mathematics is used as the language of science. So you should not have any fears, any inhibitions about mathematics, even if you haven't learned a lot of mathematics, to just know that it is a language. You have to learn how that language works. So if you see a mathematical expression, it will have the following form. Something like A equals B plus C, for example. What does that mean? You don't try to understand everything at once. There are layers of understanding. First, just as when you are learning English, you at first try to understand the structure of the sentence, the syntax, and then what the words are. Okay, so you start like that. A is a symbol of something. It's just a symbol. It's a name. So you have to create a dictionary. You have to say, well, what is A talking about? Okay? Maybe A is force. Maybe A is total force. And then equals means the value, the number, the measurement for this A, whatever it is, equals the value of whatever B is, plus, add together, addition, what is C. So that's just a mathematical sentence. It saves you, why do we use mathematics? First of all, it is very compact, short to write. Second, it's exact. Once you define what the names are, then it's clear. Okay? There is no ambiguity. Okay. Then the next step is, okay, A is force. What is force? Maybe you don't know what force is. So first you translate from mathematics to ordinary language to figure out which symbols we are using for what. And then you understand, the first layer of understanding, what is this sentence saying? Then what are these things? Okay, you learned the name used for force is A, but what is force? You don't know what force is. Okay? Maybe sometimes you will learn it later in the course. So you just understand that this sentence says something about force. It says this about force. What is force? Maybe you will learn later. Or maybe it is now the time, and then you go up and try to understand what force is. Okay? Now, of course, this is the typical structure of mathematical sentences. The verb of the sentence is equal. The most common situation. But sometimes the verb is different. This is, in ordinary language, is equal to. But sometimes you may have something like that. So this is also a verb. Verb, fiil. Okay? Is greater than, etc. So the verb of the mathematical sentence is a symbol for a relation between the quantities. How are these things related to those things? Okay. Now, most generally, the most common verb we use is equal, and most typically we have A equals a function of B. Function of B means, if you know the value of B, with some kind of calculations, you will be able to get the value of A. What kind of calculations? Well, that equation, if you are going to use it, will tell you. It will tell you add B and C, it will tell you divide, it will tell you multiply, it will tell you take the logarithm of, okay? Now don't worry if you don't know what logarithm is, but at the first level of the sentence says, to find A, you have to do this and that, whatever it is, to B. Okay? To do this and that to B to get A, most generally, this kind of mathematical relation, you say A is equal to a function of B, which means if you know B, here is a formula for you to calculate A. That's what function means. Okay? If I'm not interested in what particular function, I'm only interested in saying it is a function, there's a dependence between them, it depends on the other one, A depends on B, then I say function of, and the notation is usually from the word function, you put f of B. Okay? That's just very general structure of mathematical language. Okay? Sometimes you say, of course, A equals a function of B, C, D, because it can depend on many things at once. So let me also write that one down. It can depend on many things, and so the sentence will tell you on what things does A depend, and how do I calculate from those things B, C, D, how do I get to A? That's the general structure of a mathematical sentence. Okay? No matter how complicated, essentially it says how to get this from this and that. Right? Now, in mathematics, there is a language like this that I can write as sentences. There is also a visual language. Visual, yourself language. Which means making graphs, making pictures. So the visual language of mathematics is graphs, geometry. Okay? So this is all very simple, but I want to lay out the simple things so you know how we will proceed. Let me go to the next page. So this is our typical sentence. Now let me give this sentence in visual language. For each value of B, I use this formula, whatever it is, calculate from BA. For example, A equals B squared, so I take the square of B, B times B, get a number. So for this B, this is A. For this B, this is A. And maybe for this one, this is another A, etc. So you can calculate, or you can make your computer calculate. And then you can draw. So the standard way of presenting graphs is if you say A equals function of B, you put the value of A along the vertical axis, you put the value of B along the horizontal axis. For each value of B, you use the mathematics in the sentence, f of B, whatever that function is, that tells you how to calculate from B the value of A. So from that B, you find the value of A, and at the point with coordinates B and A, you put a dot. You join those. That shape, that curve, is the visual representation of the function, the calculation that you did. The relation between B and A, how to get from B, A. Right? Now, there is a one-to-one correspondence between the language, algebra, of çok yaşa. Between the algebraic language of mathematics and between the geometric language, between symbols and how you show them as graphs. Okay? Historically, this relation between geometry and algebra was realized and introduced by a very famous philosopher and scientist, René Descartes. He was the first person to figure out if the language of mathematics you can express it as a visual language and as an algebraic language. Maybe to make a, Descartes' thought is to make a clear convention relation between the two. Like if it's a relation between A and B, I can show it in a plane with coordinates, points I can put for A, B. Okay? So for each relation, A equals f of B, there is a picture. Geometry and algebra, and the conventions that Descartes made have survived. Like on the vertical axis you put the dependent variable, the thing that you are calculating, and on the other axis you put other one. Okay? That's called Cartesian geometry or analytic geometry. Okay? To be able to write with pictures the same ideas as you write with algebra. Which in turn, what you write with algebra is the same as things that you can write in ordinary language. Except it will be much longer, and in ordinary language things can be ambiguous. Okay? So we now understand that mathematics is, it may look hard, but essentially the first step is it's a language. It is no more than a language for our purposes. Okay? So you just have to decipher what it's talking about. What are the nouns? What daily life words do they correspond to? What pictures do they correspond to? Once you learn that, then you won't be scared because, just because it's a formula with lots of symbols tends to scare people. If you first just translate the symbols and then start thinking about what are these concepts, it will be a lot easier. Okay? Now, many symbols in science, just by convention, are always used to mean the same things. For example, in algebra, you use x and y for unknown quantities. In geometry, when you make graphs, you use x, y, z for the names of the positions, coordinates of an object. We will do that in a moment. And we don't say, one time I'll call the points coordinates x, y, z, the next time I'll call it L, M, N. Usually we don't do that. Okay? And similarly for physics concepts. We will always try to use the same symbol for energy, same symbol for voltage, etc. as we go along the course. So whenever we see a new topic, new subject, you will also learn what symbols we use for that. So that dictionary will be straightened out. And in the new edition of the course notes, we have made a table which contains at least some of the symbols that are commonly used and what they are used for and what are they